Hello everyone, welcome to this video where we will explore the most important factors for sizing battery energy storage systems, known as BESS. If you are working on solar projects or thinking about integrating storage into your plant, this content is for you. Stay until the end and discover how these parameters can optimize your results and maximize the profitability of your project. Storage capacity, measured in kilowatt-hours kilowatt-hour, is one of the cornerstones of any BESS system design. This capacity defines how much energy the system can store and release. Why is it crucial? Because it determines whether your system will be able to meet demand during periods of low solar generation. Factors such as generation and load profile, as well as weather conditions, directly affect this capacity. For example, in regions with high seasonal variability, more storage needs to be sized to cover periods of lower solar irradiation, such as the winter months. Let us now turn to the power output, measured in kilowatts kW. This parameter sets the rate at which a BESS can release power at any given time. For example, for frequency regulation and power reserve, high output power is needed, as the system must respond quickly to grid fluctuations. On the other hand, if the main objective is energy arbitrage, the power can be more moderate. The key here is to find the right balance between capacity and power, known as the C/P ratio. System efficiency, expressed as a percentage, is another key factor. It includes the efficiency of the battery, the converters, and the energy management system. For example, lithium-ion batteries are over 90% efficient, while flow batteries are typically between 70% and 80%. Why is this relevant? Because higher efficiency reduces the need to oversize the system, allowing lower initial expenditure and better energy utilization. Let's now talk about the depth of discharge, known as DOD. This parameter indicates how much you can discharge the battery without compromising its lifetime. For example, flow batteries allow a DOD of 100%, which makes them ideal for long-life applications. In contrast, lithium-ion batteries optimize their service life with a DOD of 80% to 90%. Here, the challenge is to balance depth of discharge with expected battery life to maximize long-term performance. In closing, let's combine everything we have learned. When designing a BESS system, you must consider how capacity, power, efficiency, and DOD factors interact with each other. Remember that each project has unique requirements based on its location, energy demand, and financial goals. And now I ask you, did you know that a correct configuration of the C/P ratio can reduce costs up to 20% in solar projects? If you want to go deeper into this topic and explore customized strategies for your plant, feel free to contact me through LinkedIn. Together, we can maximize the profitability of your projects. And don't forget to subscribe to the channel for more content and to keep learning about BESS systems.